Welcome to Teen Up, a podcast that digs deeper into the thoughts of teenagers' minds about the wonders of the world.
If you're new here, I am your host, Isabella.
And I'm Glenn. If you're not, welcome back.
Here's a quick disclaimer. If we made any mistakes, please email us and tell us. Thank you. This month, we are talking about oceans. We get the inspiration since we live on an island surrounded by the ocean. It should be an integral part of our life, seeing how close we are to it. Yet, it is not. On that note, we decided to know the ocean better through this month's topic.
Okay, so let us start with the definition of ocean, since, a definition of something is usually the most important part if you're trying to, understand it.
Mm-hmm.
So the ocean is a interconnected body of salt water covering the majority of the Earth's surface. So it's the ocean. There's one ocean, like the everything
Connected together.
Yeah. Like it includes all the oceans that you can think about: the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, all that.
Mm-hmm.
And I think one thing most interesting is the difference between the ocean and oceans, because I was looking like the definition of ocean and people have a lot to say about it.
Really?
Yes.
Oh, wow.
They are saying like difference between the ocean and just ocean, because like in language they think that ocean and sea is interchangeable, but the ocean is not the sea.
Why?
So the ocean refers to the biggest body of water on Earth, as opposed to if you say the sea, you don't know which one you're referring to.
Okay.
So, and then I looked a little bit deeper and see that there is a difference between ocean and sea.
Oh.
So originally I thought, ocean has currents. Ocean has all these type of stuff that sea doesn't, mainly currents. I'm thinking. But then I looked up and I saw this definition. It says, in terms of geography, seas are smaller than oceans and are usually located where the land and ocean meet. It says typically seas are partially enclosed by land.
Oh, like the Mediterranean Sea.
Yeah, that's what I'm thinking about. And like, South China Sea, it's surrounded by lands. And so I feel like this is a good definition.
Yeah, makes sense.
Technically, every ocean is surrounded by land. But you wouldn't really say like Atlantic Ocean is surrounded by land, because it doesn't really make sense.
Yeah.
So I mentioned ocean currents. So let's talk about that. Ocean currents are actually something that's, very influential to the Earth. And ocean current is basically a continuous movement of seawater, and it's generated by a number of factors, including wind and, temperature, salinity differences, all kinds of stuff. But one of the biggest contributing factor is the Coriolis force. I guess we need to explain what Coriolis force is. So Coriolis force is a fictitious force in physics.
Okay.
What is a fictitious force, you might ask? So fictitious force is not really a force. When we view forces in physics, we have different frame of reference. Okay, so a basic concept of it is, say, now I'm sitting on the ground, looking at a car, driving past me. So I would say the car is moving at a speed of 3 meters per second. That's the velocity. Okay, I'm getting very physics here. Just bear with me for a second.
Sure.
But if I'm standing on a car right now, and you're in another car, and our cars are moving at the same velocity, 3 meters per second, when I look at your car, I would say it's moving at a speed of 0 meters per second.
Oh,
So that is the frame of reference, depending on where you're looking. When we think about Coriolis force, it's something like that. So this is a force that you can only see when you're viewing it from a frame of reference that is not the inertial frame. And inertial frame is the frame that is one in which the motion of a particle not subject to forces is in a straight line at constant speed. So basically there is no acceleration.
Okay.
We will see Coriolis force acts on objects in motion within a frame of reference that rotates with respect to an inertial frame. So Earth, if we think about it, if we're in space right now, we're looking at Earth and we're just standing in space. Earth is rotating.
Yeah.
And when we throw things, it's supposed to go in a straight line because of its inertia. So when I throw things from, say, the equator to Taipei,
Okay.
I'm thinking about a straight line, right? Say I'm at Singapore, okay, around the equator, and I'm throwing things north. But see, me at Singapore and you in Taipei are not moving at the same speed.
Oh. Yes, that makes sense.
When we're on different point of the Earth, we don't move in the same speed because Earth is a sphere. And we move at a same angular velocity. When I say angular velocity, it means the whole Earth is rotating at the same speed, say 1 circle a day, meaning 360 degrees a day. And the whole Earth moves at the same time. But when you view, say, down from North Pole, you're on top of North Pole right now, you're flying, God's view. You have a knife, okay? And you cut that knife in a direction that is vertical to the pole of our Earth. And you will get many slices of circle, different sizes.
Yes.
You're in Taipei, which is north of the equator.
Yes.
And you will get a smaller circle.
Right.
Okay, let me recap a little bit. We were trying to talk about Coriolis force, and then we get into angular velocity, and now we're explaining why people move in different velocities on different points of the Earth. So you're at Taipei, you slice the Earth, you did all that.
Yeah.
You get a smaller circle representing where Taipei is at, and a bigger circle representing where Singapore or the equator is at. So it all makes sense now.
Yes.
Okay. Every day, you travel the distance of the circumference of the circle. You travel a longer distance in Singapore and you travel less distance in Taipei.
Right. Yeah.
And that's why I say you move slower when you're in Taipei.
Oh, right.
Okay. So let's just keep that in mind. And then let's go to a plate. Just a plate. A circle plate. Now we're actually going to get into Coriolis force.
Okay.
You get a plate that's turning and turning, let's say counterclockwise. And you have a ball in the middle.
Yeah.
So you're going to throw that ball and throw it out. Just like, you're in the middle, there's a ball, you want to let it roll outward. Okay? So when you're looking at it, the ball will roll in a straight line. Considering that there is no friction.
Okay.
So the ball will move in a straight line.
Yeah.
While the plate is turning. But when the ball reaches the edge of the plate already turned. So let's say the plate has a marker that is originally at 12 o'clock. And when you push the ball outward, say the ball is originally in the middle and you want to push it towards 12 o'clock. And the plate is rotating counterclockwise. And when the ball reaches the edge, the 12 o'clock point is at 9 o'clock.
Okay. So the point that you drew on the plate would move.
Yes.
Okay.
But when you're pushing the ball, you're thinking that it will reach the point that was originally at 12 o'clock.
Right.
But the point moved. So if you're standing on the plate, you'll think that the ball is moving in a curved line.
Oh.
Because you moved. And that is what we're thinking here. So there are different forces on Earth, mainly because of the sun, that is creating this temperature difference on different latitudes of Earth. So you get what Coriolis force is about, right?
Yeah, basically.
So Coriolis force cause a lot of things, including like monsoon and, the westerlies. It's all wind stuff, right? Basically, it's the driving force of that.
Okay.
I mean, of course, the sun. Let's go back to how Coriolis force is related to ocean current, because we're kind of lost right now.
Sure, that would help.
So the Coriolis force acts on winds, right? And that is why wind will not just blow directly north.
Okay, so you're saying like the wind is kind of like the ball on the plate.
Yes.
And so when the plate turns, like the earth turns, the wind and the ball is going in like a curved line, but it's actually going in a straight line.
So air will rise at the equator, and then when it reaches the higher latitudes, it will cool down and then, fall down to the ground. It will create this high pressure situation that will blow the wind back to the equator near the ground. Because, we live in a 3-dimensional world. So that's how we have the northeast wind in Taiwan, like you said.
That makes sense.
And that is also why we have westerlies, which is another wind that affects the climate in Europe and parts of America. The wind caused by the Coriolis force carries the surface water of ocean. And that forms the surface current. And ocean currents can affect the Earth's climate greatly by transferring heat from tropics to the polar regions. Or, the colder currents from polar region can also affect our climate.
Oh, wait, I know. Wait. Isn't there, a current from the North Pole and it passes like by Japan and there's like these like fish seasons brought by these currents?
Yeah. So that is just the surface current. And then we have like currents that are deeper, but we're not going to get into that because that's mostly affected by temperature and salinity. So these ocean currents can greatly influence the climate of a region, like you said. And it changes a lot of things. And it's very important, at least for us, I think. Since, like the fish that you talked about, it's like a whole industry that people can live on.
Yeah.
Anyways, that's the basic idea of like climate and ocean current. After the break, we're going to talk about the geography of ocean and mid-ocean ridge. Do I Need School to Be by Alex is a podcast show that talks to people in the creative field about the experiences that shaped them and the future of education.
Alex is about having real conversations with people, and she has a lot to offer in her experiences and from her guests.
If you are interested in her podcast, her show is called Do I Need School to Be? And we will also put down a link in the description.
Welcome back. Now we're going to talk about the geography of the ocean and what the mid-ocean ridge is.
So you might have heard of this. There is a part of the ocean that is called the photic zone.
Okay.
So the photic zone basically includes oceans from the surface to a depth of 200 meters. It is a region where, light can reach, meaning that photosynthesis can occur.
Oh, hence photic.
Therefore, it's the most biodiverse region in the ocean.
So this is like where there's a lot of like colorful sea creatures, right? Like Nemo's.
Yeah, and most sea creatures, I believe, live in this space.
Really? What about whales?
I mean, they probably don't necessarily live in this space, but, this is a place where most fish live, little fish. And if you think of it as a food chain, you need to eat little fish.
Mm-hmm.
So you cannot be too far from where your food is at. But there are also like deep ocean creatures that does not live there.
Mm-hmm.
In this place, photosynthesis allows the creation of organic matter,
Mm-hmm.
and these organic matter like algae
Mm-hmm.
is, and with these like plants,
Mm-hmm.
little fish can feed on them, and then the food chain gets bigger and bigger.
Yeah.
So that's how it all happens, because it gotta come from somewhere,
Mm-hmm.
right? You gotta have something to eat.
It's like zebras eat the grass and lions eat the zebras.
Yeah,
Mm-hmm.
exactly. It's the same in the ocean. And below the photic zone, photosynthesis cannot happen because there is no sunlight.
Mm-hmm.
And life that exists deeper than the photic zone mostly just rely on materials sinking from the above.
Oh, like the underwater vultures.
I guess, yeah, kind of.
Just a funny thought. You know how plankton, technically an algae,
Oh,
yeah,
really?
I think so. I didn't like he competes with Mr. Krabs for like the hamburger stuff. I don't watch a lot of SpongeBob, but yeah, I was just wondering how he's not dead basically because he lives with a lot of fishes.
I mean, maybe they're in the photic zone.
Yeah.
Could be. Anyway, so now we talk about the photic zone.
Mm-hmm.
Let's talk about the deepest part of the ocean,
Sure.
the Mariana Trench. And we need to understand mid-ocean ridge.
Okay.
To talk about mid-ocean ridge, we can think about the plate tectonics first.
Mm-hmm. This is getting deep.
Uh-huh. So you know how there are a lot of plates
Yeah.
on Earth?
Yeah.
Say the Eurasian plate.
Mm-hmm.
And then we have like African plate, North American plate,
Mm-hmm.
Pacific plate.
Isn't there like a Filipino plate?
Yeah, Philippine plate.
Yeah.
So there are big ones, smaller ones, and that is basically how like earthquakes happen.
Mm-hmm.
So mid-ocean ridge is where the mountains under the ocean is.
Mm-hmm.
It's where the lava comes out of the crust and then cool down and become the new plate.
Mm-hmm.
And then the older part of the plate will be pulled back into the mantle. So the mantle is a part of the Earth, because we all know Earth is a sphere.
Right.
The outer part is called the crust.
Mm-hmm.
Of course, there are like a lot of other layers of it,
Mm-hmm.
but let's just say the crust.
Okay.
And when we go in, we have the mantle, and then it's the core. We have a liquid core and solid core, but that's none of our concern.
Yeah.
So we have the mantle, and that's where all the lava is at.
Yeah.
And these lava, they would, come out from mid-ocean ridge.
Oh, okay.
So it's basically like the plate is, expanding, and then at the same time, the older part is getting recycled back into the mantle.
Mm-hmm. Mm-hmm.
Just melting the plate back into the mantle.
Mm-hmm. Wait, so are you saying that one day all the land would be melted back?
I mean, to my understanding, it's more like a recycling.
Yeah, that makes sense.
And I don't know, it probably had already. Like, how do you know if you are drinking the same water that you peed out,
Yeah.
10 years ago?
Mm-hmm. That's true. That's true.
But it's the cycle, right?
Mm-hmm.
The
Mm-hmm.
cycle of life.
Oh wait, yeah. This reminds me. You know how like they recycle and they like move the land would move both ways and go down into the earth and come up again.
Mm-hmm.
Side note, you know how Hawaii is like made of what is that now? 8 islands? And there's like this volcano part where it just shoots lava and it creates a new island. And
Wow.
it just like right now, Big Island is located. That's one of the island's names. It's located on that volcano, and all the islands are moving towards one way because I guess they're getting like moved a certain way to get recycled one day.
Oh,
Yeah. And a new island is actually forming right now under the sea.
that is so cool. Anyways, so every ocean basin has a mid-ocean ridge. And that creates a long mountain range beneath the ocean.
Oh,
And it's basically just a huge mountain range that's under the sea. So we need to get back to how we get the deepest part of the ocean.
That's right.
There are two forces that's pushing this movement. The first force is the force that, when lava comes out, it gets pulled down by gravity. And this downward force will then be changed into this force that is horizontal. So it, just pushes the rock, I guess, toward the trench.
Oh, okay.
And the trench is where the rock get melted and recycled back into Earth.
Oh.
And the other force is the pulling force from the trench, since it's getting melted down and then, it's pulling down.
So are you saying that the Mariana Trench will never, disappear? Or is it gonna, move, the trench location?
I mean, I assume it would, because everything on Earth is moving. And I guess we can't really say, oh, it's here today and it's there tomorrow, because it's not like it's moving at a very great speed.
Yeah, that makes sense.
But, I would assume that it moves. So it's kind of related to the ocean. And the more important part is that it's related to plate tectonics. And that is something that's related to the earthquakes.
Oh, yeah.
And I just feel like it's something that we should know.
Like we had an earthquake yesterday.
So that's basically it for this very, very brief introduction to different parts of the ocean.
And next week, we will talk about different types of technologies in the ocean. Thank you for listening to this episode.
We will upload a new episode every Thursday.
Remember to like, follow, and share our podcasts with your friends and family. You could also share your idea and thoughts with us on our Instagram at teenup.podcast.
Don't forget to like, subscribe, and share our channel.
Thank you and bye.